Now that we've seen how to create parts and assemblies in Solidworks, let's take a look at how to create the third major file type, a drawing file, or also referred to as a detailed drawing or manufacturing drawing. There are several ways that you can create a new drawing. One way is similar to the way you would create a new part or assembly in Solidworks, by using the File drop-down menu and selecting New. Or you can create a drawing with the part that's currently open by clicking Make Drawing from Part. You can also use the drop-down of the File New icon here, and select the Make Drawing from Part or Assembly option for the file currently open. I'll go ahead and click on the File New icon to bring up the new SolidWorks document window. Notice that here, you can select Drawing, which shall use the default template, or you can press the Advanced option here, and if your company has a custom drawing template, you would be able to find it here. We don't have any custom drawing templates available right now, so I'll go ahead and return to the standard Novice menu, select the drawing template, and click OK to create the new drawing file. The first thing SolidWorks prompts me to do is to select a sheet size and format. I'll be going into more detail later on about what exactly the sheet format and size are. But basically, you should understand that the sheet size controls the size of the paper that the drawing would be printed on, and the sheet format contains the information such as the title block, pre-existing notes or annotations, and other such information. As I click through the different sizes and formats available, you can see a preview on the right side and also see whether it has a portrait or landscape orientation. I'm going to go ahead and choose the A landscape sheet format for this drawing and click OK. When I do, you can see that we now have a blank drawing template, which has the title block on the sheet just as we saw in the preview. Notice on the left here, we have the Model View Property Manager open. This is one way to add new views into your drawings, and if the Start command when creating new drawing option is enabled, it opens up by default when you create a new drawing. We can select a part or assembly from the list of open documents, or use the Browse button to search for a part or assembly file from your hard drive. I'll click Cancel, since I already have my bracket part highlighted from the Open Documents list, and I'll click Next to continue. From here, you can choose from the different standard view orientations to include options such as bottom, front, top, isometric, right, left, or back, as well as a list of additional orientations here. When you select a view, such as the top, you drag it on your sheet and simply click to place it. Instead of inserting a drawing view using this method, I'll go ahead and hit the Escape key to cancel out of the Model View selection. In the next lesson, I'll show you a different way to insert drawing views that I like a little better. In the previous lesson, I started a new drawing template, and we saw that when I started the drawing, I had the option to add a model view. You can find the Model View icon on the View Layout tab of the Command Manager. You can always click this icon to bring back the Model View Property Manager, and like we saw before, you can browse for an open document and press the arrow to see a list of views that you can drag and place on the sheet. Instead of using that method, I'll hit Escape to cancel. Here, I'd like to show you another easy way to create views that might seem a little more intuitive. Here in the task pane is something called the View palette. If I click on it to expand the menu, I can use this drop-down to choose from a list of files that I might have open. I'll choose the bracket part, since that's the part we want to create this drawing for, and underneath, you can see a preview of all the different views that we currently have available for the model. To create the view, all I have to do is select it from the View palette and drag and drop it onto the drawing sheet. This is the same functionality that is available using the Model View command we saw earlier if we would have clicked into Place the View instead of hitting Escape to cancel. Once you place the view, you're automatically placed into the projected view mode, as you can see by the Property Manager on the left-hand side of the SolidWorks interface. If you drag the mouse cursor away from the model, you can see a projection of the model. I'll click here to place the top projection. In this case, the drawing is using a first angle projection, which means that the top projection is showing the bottom of the part. Later on, I'll switch the drawing to a third angle projection, which will cause this view to show the part from the top instead of the bottom. There's a lot to discuss when differentiating first angle projections from third angle projections, which I won't cover in this lesson. Notice that I'm still in projected view mode, and I can continue clicking to place additional views, such as the right view orientation. You can also project an isometric view if you would like to do so, as well as any other projected view in any direction, even if they're placed outside of the drawing sheet. Once you have all the projected views you would like to create in place, simply press Escape to exit the Projected View menu. One aspect that is really nice and convenient about creating projected views, as opposed to simply dragging and dropping additional views from the View palette, is that the created views are automatically aligned. So, if you move the base view, the projected views move with it and maintain the alignment. You can also select the base view by double-clicking its border, and with the view selected, you can change the display style. For instance, you can use Shaded with Edges, or Hidden Lines Visible. I'll use the standard Hidden Lines Removed for this template since I don't want to show any hidden lines at the moment. You may have noticed that when I changed the display style for the parent view, the display style had also changed for the projected views, since they're linked. However, If I go ahead and double-click on the border of one of the projected views to select it, I can change the display style for just that view. If you want to create a view that's completely unlinked, that's easy to do as well. All you have to do is use either the View palette to drag and drop another view anywhere onto the sheet, or, since we skipped it earlier, let's use the Model View Property Manager. I'll select the bracket, click Next, and I'll drag a standard view onto the sheet by selecting it. And I'll click here to place it. As before, you can click the border to select and drag the view around the sheet to move it. And that's the basic way that views are added to a drawing. There's a couple things I'd like to show you before we move on. You may have noticed when we projected the views that this may or may not look correct to you based on your drawing standards. The first thing I want to show you is right here at the bottom. You can see that we're currently working in the units of inch, pound, and seconds. However, since this part was modeled using millimeters, it's probably a good idea to change the units of the drawing template to millimeters, grams, and second. This way, when we dimension the drawing and detail it later on, our values will be consistent in millimeters instead of inches. The reason this drawing was in inches by default is that when I selected the template to start this new drawing, this particular template uses the inch, pound, second unit system. As I mentioned before, you can set up all sorts of custom templates for various unit values such as millimeters, metric, inches. In this case, I'll switch the template to use the units of millimeters. There's another thing I'd like to show you. As you can see, the sheet scale right here is 1 to 2. You can also see the sheet scale down here in the title block is also set to 1 to 2. If you want your views to be a different size, you can click to select the view, and here in the Drawing View Property Manager, you can choose to scroll down to the Scale property. Here, you can choose to use the same scale as the sheet, or you can use a custom scale and choose from the different scales available on the drop-down menu, say 1 to 12 to make the views really small, or perhaps you want to double the size of the views by selecting 2 to 1. Notice that this does not look very accurate, nor do the views fit on the sheet any longer, so I'll switch back to using the default template sheet scale. You can change the display style from the Property Manager as well, if you don't like using the heads-up toolbar. And you may have also noticed that when I changed the sheet scale, since I selected the parent view, the projected view sizes also changed, but not the size of the isometric. Now that we've seen how to adjust the scale, I do want to show you how to adjust the projection. This view might look incorrect to you. So if you right-click Sheet from the Feature Manager and select Properties, you can see the Type of Projection option here, along with some of the options that were specified earlier, such as the sheet scale, sheet size, and sheet format. I'll go ahead and change the drawing sheet to a third angle projection, and when I click OK, you can see all the views on the drawing sheet update and now show a third angle projection of the model views. This view here used to be showing the bottom of the part, but is now showing the view from the top of the part. At any time, you can switch between the two projection types, making your drawing flexible and easy to use. If for any reason you didn't create projected views when you placed your initial drawing view on the sheet, you can create a projected view from any view in a drawing simply by choosing the projected view icon. If your drawing has hardware that has threads, you can choose how you want the threads displayed, either by selecting a high or draft quality cosmetic display. But the main thing that you're asked to do is to select the view that you want to project from. I'll choose this view here, and notice that when I drag the model in any direction, you can see the projections of the selected view. Click to place the view at the desired location, and hit the Escape key on your keyboard to exit the projected view menu. If you would like to delete a view, simply click on its border and press the Delete key on your keyboard. This brings up a confirmation dialog box where Solidworks asks if you would like to delete the view. Click Yes to confirm, and the view is deleted. Once you have all the views in place for your drawing, the next common thing to do to create a production drawing is to annotate it by adding dimensions, notes, and other types of details to the drawing to convey the different design information that you would need to manufacture the part or the assembly. You can do this by switching to the Annotations tab of the Command Manager. The quickest way to add dimensions to a drawing is by first directly importing the dimensions from the 3D model. To do this, I'll select the Model Items icon to bring up the Model Items Property Manager. This feature allows us to automatically import many different aspects of your 3D model straight to the drawing for you. The first thing you have to do here is specify your source. You can import model information from just a single feature on the model or the entire model. I'll choose the entire model as my source. You can also choose whether you want to create annotations only to specific views by specifying the destination views here, or simply check this box if you'd like SolidWorks to automatically distribute the information between all of the available views. In the Dimensions area of the Property Manager, you can see that I'm choosing to import dimensions that are marked for drawing, but you can also import dimensions that are not marked for drawing, as well as instance and revolution counts, and whole wizard profiles. You can also import annotations, reference geometry, and even include items from hidden features. As you can see, there are a lot of options for you to import into your models. Right now, I'm just going to import the dimensions that are marked for the drawing into all of the views from the entire model, and I'll click the green check to continue. As soon as I do, you can see that the template updates and some dimensions appear right away. Now this is a pretty quick way to get basic dimensions into your model, but it also may require you to do some cleanup to make them more organized and easy to read. Cleaning up dimensions is very easy. You can simply move the dimensions by clicking and dragging them and placing them anywhere on your sheet to make your drawing look the way you would like it to. Notice that the dimensions can also snap to inference lines, just as we had seen with sketch entities. You can also choose to flip the dimension of the arrows by simply selecting the dimension and clicking on the arrows to flip their direction. I'm going to clean these dimensions up a little bit as well here. Another feature that can be very convenient is being able to move and copy dimensions between views. To do this, you can hold the Control key on your keyboard while clicking and dragging a dimension, as you can see here. If you need to delete a dimension, simply click on the dimension and press the Delete key on your keyboard. You can also move a dimension from one view to the next by holding the Shift button on your keyboard while clicking and dragging the dimension from view to view, as you see here. As you can see, there are many features that Solidworks provides that lets you import basic dimensions into your drawing and make it look just the way you want. In the last lesson, we saw how to import dimensions that were marked for drawing by using the Model Items tool from the Annotations toolbar of the Command Manager. But what about dimensions that weren't marked for the drawing, or those that didn't appear when I ran the Model Items tool and imported the dimensions? Well, I could just launch the Model Items tool again and select dimensions that were not marked for drawing and try to import them that way. But instead, notice that we also have the ability to use the Smart Dimension tool, as well as a variety of other dimensioning tools from the dropdown. I often find myself using the Smart Dimensioning tool more often than not when adding additional dimensions. Dimensioning in a drawing works just like dimensioning in a sketch or any other aspect of SolidWorks. Simply select the items that you'd like to create the dimension between, for instance, the overall height of this view orientation. SolidWorks makes it very easy to automatically locate the dimensions with the use of these rapid dimensioning icons, or you can click anywhere in the drawing to position it. I'll use the Rapid Dimensioning tool here to create this bottom width dimension. One thing you may have noticed is that certain dimensions appear in black, while other dimensions appear in gray. These are called driving and driven dimensions. Driving dimensions appear in black and actually control and change the model geometry, whereas driven dimensions appear in gray and cannot control or change the model geometry. Notice I can double-click a driving dimension, and the dimension spin box appears where I can adjust its value if I'd like. However, if I double-click a driven dimension, no spin box appears, and I don't have the ability to adjust its value. Between using the Model Items tool as well as the various dimensioning tools available from the drop-down of the Smart Dimension tool, you can continue going on and adding all the dimensions that your drawing may require for manufacturing. One of the nice things about SolidWorks as a parametric CAD system is that it maintains associativity between parts, assemblies, and drawings. This can save you a lot of time, simply because you don't have to create any of the line work to create each of these views, as SolidWorks can automatically create views from the 3D CAD model of the part. However, the associativity goes further even beyond that. As I zoom into this view here, I can edit any of the driving dimensions simply by double-clicking them in the drawing and adjusting the value. Let me increase this dimension to 170 millimeters. If I click on the rebuild icon at the top of the screen, you can see the view updates, along with all of the other views on the drawing sheet. Going further, I can click on a view and open the part from within the drawing. When the part file opens, you can see the dimension updates in the part as well. This is also the case if the part was part of an assembly. If I adjust the dimension value back to 150 millimeters from within the part and click Rebuild, you can see that the part returns to its original size. And when I switch back to the drawing, you can see that the dimension automatically updates here as well. This type of associativity can be very helpful, because whenever you make a design change for a part, you only need to make it once, and anywhere the part resides will update accordingly. Besides adding dimensions, another common task when working with drawings is adding annotations such as notes, hole callouts, and tolerances. However, before I add any annotations to this drawing, I'd like to make the sheet slightly larger since the view orientations and dimensions are taking up most of the sheet space that is available. To adjust the sheet size, I'll right-click on the sheet in the Drawing Feature Manager tree and select Properties. Under the Sheet Format and Size option, I'll increase it from an A landscape to a B landscape and press OK. When I do, the drawing updates to a larger size, which may require you to reposition the views on your sheet. With the views repositioned, I'll go ahead and create our first annotation by adding a note. Here is the Note tool located on the Annotations toolbar. To add a note to your drawing, simply click the icon to bring up the Note Property Manager, and then click on the drawing sheet to position your note. I'll add a note here which states, all fillets 3 millimeters unless otherwise specified. And then once you're done, hit escape. Notice that the note will reappear by default, so you can hit escape on your keyboard to exit out of it. I'll zoom in here to view the note a little more clearly. To edit the note, simply double-click on it to activate the text box. This also brings up a formatting toolbar, which includes various formatting options similar to what you would find when using Microsoft Word. You have the option to make your text bold, change the font size, as well as other formatting options that you should be familiar with. You can also drag it anywhere on the sheet. And as you can see, adding notes is very simple and is one of the easier to use annotation tools that Solidworks offers. Another annotation tool that I would like to show you is the Hole Callout tool. I'll select the tool from the command toolbar. Click once to select any hole, and click again to place the hole callout. This callout is driven through any hole wizard information from the part file. So, as you can see here, the dimension appears in gray, and it's a driven dimension. All of the annotation tools are pretty straightforward and easy to use, so I recommend practicing using them in order to become familiar with them. In this lesson, there are a couple more common view types that I'd like to go over. One of them is the Detail View. You can find the icon for the Detail View on the View Layout tab of the command toolbar. Detail views are used when you would like to show a detailed portion of another view, which produces a larger scaled image to give a clearer picture of a specific area of the model that you want to show. I'll go ahead and click on the Detail View icon, and when I drag my cursor onto the drawing sheet, you can see a pencil with a circle appears. In order to create a detail view, you first have to sketch a circle around a portion of the model that you would like to show more clearly. In this case, I'll zoom in here and sketch a circle around one of these holes. Then, I can click somewhere else on the drawing sheet to place the detail view, and you can see the detail view of the hole we created. From the annotation, notice that you can see that this is detail view A, and the scale for the image is 1:1, which is larger than our sheet scale of 1:2. I'm going to add some more dimensions in order to show the distance of this hole from the edge, since we don't have that anywhere else. It is important to note that the dimensions shown in the detail view are the actual dimensions. So even though the view size appears in a scale where it looks larger, these dimensions are the same as they would be in any other view of any other scale size. If you ever need to edit the detail view, you can zoom in and find the circle that we created, circle A, click on the circle, and if you click and drag it to change its size, the detail view updates. Another common view that you'll find in manufacturing drawings is the section view. A section view lets you show a cut portion, or, in other words, a section of the model, in a drawing view. To create a section view, click the Section View icon on the View Layout tab of the Command Manager. The Section View Property Manager has quite a few options here, and SolidWorks gives you the flexibility to create any kind of section view that you could ever possibly need, such as a half section. All of the options are very straightforward. Just look for the type of cut you want to make, and when you drag the mouse over a drawing view, you can click to place the lines and create the cuts. Views like a half section or an aligned section are a bit beyond the scope of this course, but I'd like to show you how to create the most common type of section view, a vertical or horizontal cut that sections through the entire model. I'll switch to the Section tab and select the cutting line. You can choose either the vertical or horizontal icons depending on which way you'd like to cut the model. I'll choose vertical. Next, zoom in to the drawing view you'd like to section and simply click to place the section line. Notice, you can hover over existing geometry to snap the section line exactly where you want it. For instance, right down the center of this hole. Once the section line is in place, a pop-up toolbar appears, letting you add additional complexity to your section line. For instance, an offset or a notch. I just want a straight section line, so I'll click the green check and a preview of the section view appears and is attached to my cursor. Next, I'll just click anywhere on the drawing sheet where I'd like to place the section view. The View Property Manager appears, and I can adjust the label. For instance, change it to section AA. Flip the direction of the section arrows, and loads of other properties. Again, I won't go over them all here, but know you have lots of customization ability, should you choose to do so. I'll click the green check, and the view is created. To edit the view's properties, just click the view's border to bring up the Property Manager again. Creating a drawing for an assembly is done the same way you create a drawing for a part. I'll use the File New Icon dropdown and select Make Drawing from a Part or Assembly in order to create a drawing from this assembly file. The first thing I have to do, just like we saw with the part drawing, is select a sheet size and format. I'll choose the B landscape, press OK, and a blank drawing sheet opens. I can use the View palette to drag and drop any views I'd like onto the sheet. I'll drag in the isometric view, and also the exploded isometric view. One thing you should note is that the exploded isometric view will only be available to you in the drawing if you have an exploded view created in the assembly file. So, you won't have the ability to show an exploded view in a drawing unless there is an exploded configuration in the assembly file. Another note I'd like to add is that even if the exploded view doesn't appear by default in the view palette, you can right-click any view and choose to show it in its exploded state. Or, you can right-click a view that's currently exploded and choose to show it in its unexploded or collapsed status. Just like with parts, you can delete a view simply by clicking it on its border and pressing the delete key on your keyboard. Solidworks asks if you want to confirm the delete, and I'll go ahead and click yes. If you need to edit or make any changes to the exploded view, or if it doesn't look the way you like, you can simply select the view, and you can open the assembly straight from within the drawing. Then, switch to the Configurations tab and activate the exploded view. You can right-click on the exploded view in the Configurations Manager tree and select Edit Feature. You can make your adjustments to the exploded view from right here, and the exploded view on your drawing sheet will update to show the changes made in the assembly. One feature that I'd like to point out here is the ability to add an exploded line sketch. I'll click on the Exploded Line Sketch icon from the Exploded View dropdown. And to create the exploded line sketch, all you have to do is select the items that you'd like to connect using what is called a root line. I'll choose these cylindrical faces to create a root line, which shows the path of an assembly in an exploded line sketch. And I'll click the green check to create the exploded line. Notice that the exploded line sketch tool stays open, so I can continue adding root lines for the assembly hardware. Notice, after making your selections, you can also use the right mouse button to quickly access the green check to save you a little bit of time. Once you've added the desired root lines, you can press the X to cancel out of the Explode Line Sketch tool. You'll notice that you're still in Edit Sketch mode, and I'll exit the sketch. You see the different explode lines have been added into the assembly. Now when I switch back to the drawing file, you can see the isometric exploded view has been updated, and all the explode line sketch items that we added are there. Another common item found in assembly drawings is a bill of materials, or a BOM, or a BOM. Solidworks makes it very easy to insert a bill of materials table into your drawings. To do so, you simply go to the Insert drop-down menu, and under Tables, select Bill of Materials. The first thing I'm asked to do is to specify a drawing view that contains the model with the parts that I would like to include in the bill of materials. In this case, we only have one view that has our assembly in it, so I'll select it here. The Bill of Materials Property Manager then appears, where you can first select a table template for your bill of materials. You can browse for a template by clicking this icon here, but I'll just use a standard template in this example. Another option that you can select is to attach your bill of materials table to an anchor point. If you have an anchor point in your drawing, you can attach the bill of materials to that point to have a set table position, instead of allowing it the freedom to be placed anywhere on the sheet. I'll leave this option unchecked. Another important option I'd like to show you is the BOM type. We saw earlier how you can create subassemblies within an assembly, and so you can choose the top-level parts only option, which would be to include subassemblies in your BOM. You can choose to display parts only, or you can choose to display subassemblies indented in your parts list. This BOM type option is mainly important if you're dealing with an assembly which has subassemblies. In this case, however, none of these options will affect the appearance of our bill of materials, since we do not have any subassemblies within the existing assembly. I'll leave the rest of the options here in their defaults, and go ahead and click the green check to continue. When I drag my cursor into the drawing sheet, you can see a preview of the bill of materials appear, and I'll simply click anywhere to place it. When I zoom in, you can see a list of item numbers, part numbers, along with the quantity. If you ever need to make any changes to the BOM or do not like the way it looks, you can click this square icon here in the top left corner to bring up the Bill of Materials Property Manager. Here, you have full customization ability for your bill of materials. To edit a cell, you can simply double-click on it, which I'll do here. Notice, this brings up a SolidWorks warning, which states that the cell value is linked to a property in an external model. You can either choose to keep the link, or you can break the link and override any of the existing values. For this part number cell, I'll click Cancel, simply because I don't want to edit the cell and I'd like to keep the linked values. However, I'll click on this description cell and choose to break the link. I'll type in a description of the wheel here, say its material, stainless steel wheel. Again, you have full functionality of being able to customize your bill of materials however you want. Anytime you want to edit your bill of materials, all you have to do is click this square icon here, or click in a cell. You can add additional rows or columns, override quantities, or do anything else that you would possibly need to do with your parts list or bill of materials. There's one last thing I'd like to show you before wrapping up this section on drawings. In the previous lesson, we created a bill of materials with item numbers to be added to our drawing sheet. But how do we know what the item numbers are referring to in the drawing? A common way of solving this problem is by creating annotation balloons in order to indicate the parts you see in the drawing view based on how they are referred to in the bill of materials. Solidworks has a very useful tool called Auto Balloon that can do this for you automatically. You can find the feature by navigating to Insert, Annotations, Auto Balloon. When I select it, right away you can see that the balloons appear. You can position the balloons however you want by simply clicking and dragging them. And if you're using SolidWorks 2012 or newer, the balloons will be created and automatically attached to what's called a magnetic line, as you can see here. From the Auto Balloon Property Manager, you can choose from the various options available to customize your balloons, such as the style. You can change the shape of the balloon into a triangle, a diamond, or you can choose what to display in the balloon text, such as the item number, the quantity, or any other property listed here. I'll leave the rest of the options as they are, and go ahead and click the green check to continue. You can see that balloons are added, and you can position them individually using inference lines by selecting them. You can also adjust where they are pointing by selecting the tip of the arrow and dragging it to a new position. Notice that when the balloon arrow is positioned onto a face, it appears as a dot, just as I had specified in the Balloon Property Manager. If I drag the pointer back to an edge, you can see that it again appears as an arrow. Let me show you the magnetic lines feature that I had mentioned earlier. When I click and drag a balloon, you can see a line become highlighted. You can click any balloon and drag it away from the magnetic line to position it individually. But for any balloons on a magnetic line, you can simply position them in different locations along the lines like you see here. Or move the line itself to move them all together, keeping them aligned and well organized on your drawing sheet. There are several ways to create a drawing file in SolidWorks. I will create a new drawing from this part by clicking the File New icon and selecting Drawing. First, I'm going to select sheet size A ANSI Landscape. And make sure the units are set to IPS. Next, I'm going to edit the properties by right-clicking anywhere on the drawing sheet and clicking Properties. In the sheet properties, I can change the scale size, select a different sheet format, and change the type of projection to use. I want to make sure all the views are clearly seen, so I'm going to set the sheet scale to 2:1 and leave the sheet size as is. Next, I'll select the type of projection I'll be using. Type of projection refers to the orthographic projection of a part. There are two different ways of projecting a part onto a drawing sheet: first angle and third angle. First angle projection refers to a drawing layout where the isometric view is located in the bottom left corner, the right view in the top left corner, the front view in the top right corner, and the top view in the bottom right corner. This standard is used in many European and Asian countries. Third angle projection refers to a drawing layout where the front view is located in the bottom left corner, the top view in the top left corner, the isometric view in the top right corner, and the right view in the bottom right corner. This standard is what we use in the US, so I'm going to select third angle projection and click OK. Now that the sheet is set up, I'm going to add the views. First, I'm going to add a model view. From the Property Manager, I can select a part or assembly from the Open Documents window or click on Browse to select a different file. The part is already highlighted in the Open Documents window, so I'll click Cancel and then Next. Remember, we are working with third angle projection, so I'll click on the front view icon and place it in the bottom left corner. Because the Auto Start Projected View option is enabled by default, I'm automatically able to begin placing the projected views. To add the top, right, and isometric views, I'll drag the cursor to the corresponding locations on the drawing sheet and click to place. Next, I'll add the dimensions. I'll click on the Model Items icon from the Annotation toolbar. Model Items directly imports dimensions from a 3D model, so it can save you time when you're creating a drawing with many dimensions. SolidWorks first prompts us to select a source to import the dimensions from. I'll select Entire Model. The Dimensions section allows us to select what dimensions to import, such as the number of instances in a pattern, tolerances, and various hole wizard properties. Our part is simple, so I'll just select Marked for Drawing. I'll leave the other options blank and click OK. As you can see, the dimensions are not as clear as they could be, so I'm going to take a few minutes to clean them up so that it's easier to read them. You can move a dimension by clicking it and dragging it on the drawing sheet. If I switch over to view the part file, you can see that the part has a dark powder coat finish. The intent of a drawing is to communicate all the design information of a part to another person for manufacturing, so I'm going to change the display state of one of the views to reflect the appearance of the part. I'll switch over to the drawing again and select the isometric view. From the heads-up toolbar, I'll click on the Display Style drop-down menu and click on Shaded with Edges. I'll also add a note to communicate that the part has a black powder coat finish. From the Annotations toolbar, I'll click on the note icon, place it in the top left-hand side, and add the following note. To finish the drawing, I'm going to give a title to the part. I can either right-click anywhere on the sheet and select Edit Sheet Format, or go to the Edit drop-down menu and select Sheet Format. I'll add a note in the title box, and the drawing is complete. In this exercise, I'll be creating and detailing a drawing for this holder component. Instead of using the Model View icon, I'll insert a part view using the View Palette Property Manager. I already have the part open, so I will go to the File New drop-down menu, select Make Drawing from Part Assembly, and select Sheet Size A ANSI Landscape. Notice that the View Palette task pane appears. The drop-down menu here allows me to select which open part or assembly I want to use, and this button allows me to browse through other documents that aren't open. Since I selected Make Drawing from Part Assembly, the part is automatically chosen as the part to use, and the different views available are displayed on the bottom half of the view palette. I'm going to drag the front view to the bottom left corner to begin the drawing. When I release the mouse to place the view, notice that SolidWorks automatically switches to the Projected View tool. This makes it easy to place the top, right, and isometric views. I also want to insert two additional views, a detail view of one of the holes and a section view of the front view. Before I add these views, notice that this drawing sheet is going to be too small to show all the views clearly, so I'm going to change the sheet size. I'll right-click anywhere on the sheet, click Properties, and change the sheet size to B ANSI Landscape. Notice that the parts are now too small. If the scale size remains the same, the drawing will have too much empty space. To fix this, I'll click on the front view to make the Property Manager appear. I will change the scale options to Use Custom Scale, and select 1:4 from the drop-down menu. Notice that all the other views update as well. That's because the other views are using the parent scale. If I select Use Sheet Scale, notice that the view updates to a smaller size. I'll select Use Parent Scale again. To add a detailed view of the hole, I will go to the View Layout toolbar and click the Detail View icon. I'll sketch a circle around the top right hole in the front view and place it in the top right corner of the drawing sheet. Next, I'll add a section view of the front view. When working with section views, make sure you select the correct option. I want to display the entire cross-section of the model, so I will select Section. I will create a vertical cut line that passes through the origin and place it in the bottom right corner. I'm going to edit the font size of the notes here so that the text is more legible. Now that all the views are in the drawing, I'll add dimensions. First, I'll make sure the units are set to IPS. Next, I'll click on the Smart Dimensions icon and manually add dimensions to the top, right, detail, and section views. I'm going to manually insert the chamfer dimensions by adding a note. I'll select the note icon, drag the note box near the chamfer edge in the top view, and add the dimensions to the note. The last dimensions I'm going to create are the hole dimensions. The holes were made using the Hole Wizard feature. Solidworks' Hole Callout tool automatically adds the dimensions to the holes that were created using the Hole Wizard. I'll click the Hole Callout tool from the Annotation toolbar, select the top left hole, and click to place the dimension. Notice the display of the text. This value here tells me the number of instances included in the callout, and the text "through all" tells me that the hole goes all the way through. To finish the drawing, I'll edit the sheet. First, I'm going to add a title through the part file. I'm going to switch over to the part, go to File, and click on Properties. In the Configuration Specific tab, I'm going to add the title by selecting Description from the drop-down menu here. I'll make sure the type is set to text, and enter Holder. I'll click OK. And when I switch over to the drawing, notice that the title has been automatically updated. Finally, I'm going to manually update the scale size. I'll select Edit Sheet Format, update the scale, and the drawing is done. Of course, there are always going to be several ways to create a drawing, and this is just one way to go about doing it. Creating an assembly drawing is incredibly similar to creating a part drawing, but there are important differences I'd like to show you. I already have the brace assembly open, so I'll go to the File New drop-down menu and select Make Drawing from Part Assembly. I'll select Sheet Size C ANSI Landscape and click OK. From the View Palette task pane, I'm going to insert the isometric view in the bottom left corner. This is the only view I'm going to be placing into the drawing, so I'm going to change the scale size to 1:1. In the current view, it's hard to see all the components that make up the assembly, so I'm going to change the default view to an exploded view. To do this, I'll select the isometric view so the Property Manager appears. The first selection box asks us to choose a reference configuration. I want to show the exploded view, so I'll check this box here. When I do, a drop-down menu appears that lets us choose which exploded view we want to display. Since I only have one exploded view, I'll just click OK. You can also select an exploded view by right-clicking on the assembly, clicking Properties, and checking the Show an Exploded State box. Next, I'm going to add a bill of materials, or BOM. I'll go to Insert, Tables, and click on Bill of Materials. I'll select the isometric exploded view as the drawing view. In the Property Manager, I have the option to select a BOM type of Top Level Only, Parts Only, or Indented. Although this assembly was made using multiple subassemblies, I will select Parts Only and place the BOM in the top right corner. The BOM is smaller than I would like, so I'm going to make a few changes to make it clearer and easier to read. Let's take a closer look at the BOM. Notice that all the part number and description cells are already populated. This is because these cells are linked to the properties of their corresponding external models. If I open this part here in a new window, you can see that this part is saved under the file name L6EX3PRT01, which the BOM automatically references as the part number. Since the BOM type is set to Parts Only, it also orders the parts in the same sequential order as they were assembled. If I go back to the open part and open up the properties, you can see that this part already has a description with the text expression Boom Black Finish. This property is linked to the BOM description cell. If I can make a change here to the description, the BOM table automatically updates. Next, I'm going to add balloons. To save myself some time, I'm going to use the Auto Balloon feature. You can access Auto Balloon by going to the Annotation toolbar and clicking on the Auto Balloon icon, or by going to Insert, Annotations, and clicking Auto Balloon. The first thing SolidWorks prompts me to do is select a drawing view to insert balloons. I only have one view, so I'll select it. In the Balloon Layout option, I'll select Layer Balloons to Top, and click OK. Now, I'll add a vertical magnetic line to the right, and rearrange the balloons to clean up the drawing. Finally, I'll make a few edits to the sheet format to finish the drawing. If you look at the drawing number text, it doesn't fit in the box. To make it easier to read, I'm going to change the font size to 20. I'll do the same for the title to make it uniform. Notice that the scale size doesn't match with the scale of the brace assembly. To edit it, I'll double-click on it and add the scale I used. Alternatively, you can change the scale size by editing the sheet properties. Right-click on the sheet and click on Properties. From here, you can manually set the sheet scale to anything you'd like. I'll change it to 1:1 and click OK. If I select the Exploded Isometric View again and edit the scale option to Use Sheet Scale, the view will remain the same size because the sheet scale and the custom scale originally used are the same.